All right. Good morning, everybody. My name is Rahul. I'm the founder and CEO of AI Hero, and today I'll be talking about spot checks and why it is a critical MLOps activity. Awesome. So a little bit about me. Like I said, I'm the founder and CEO of AI Hero. Previously, I was a researcher at USC. That's where I did my master's. And for about 7 years, I was a researcher at Toyota ITC in Mountain View, California. Following that, for about 3 years, I was a director of data science at Figure 8 or Appen. You might know them as an awesome data annotation company. At Figure 8 and Appen, I built out an architecture serving machine learning models in production. And this was, we had about 36 models in production, serving about 1.2 million predictions per day. I am super passionate about democratizing AI, and I'm interested in building these experiences that are at an intersection of how AI and UX work together. And so I've been building AI Hero, which is improving how we teach machines and making it easier for everybody to build AI. Our story starts when you've deployed your model. So first of all, congratulations, right? It's been a great achievement. You've trained your model through the Jupyter Notebook and got it out into a server that's now hooked on to your user experience and serving models in production. So now the right question to ask is, now what? And an easy answer, which almost everybody will gravitate towards, is to automate all the steps, right? And that's what we want to do. We want to make things fast. So we start saving all our predictions for the future, right? And you can see this at the bottom right. You can just start logging stuff and saving all these predictions so that we can train our models later on. Maybe you want to have an automated nightly build, right? And so that's an amazing thing to implement. Let's do that. Hey, we need some data annotated. Why don't we just integrate our data annotation with our vendor so that we can get data annotated automated in an automated way? Or finally, once our model is trained, we deploy. And all of these are great steps to do what you originally set out to do, which is you defined your model, you built it out, and now you're improving on the model by adding more data to it, right? But then the VP of engineering comes up and she says, well, this model is a great start, but can we do better? And so that makes you think, right? Like what she's referring to is not, can we make it more shinier technology? Can we use more shinier technology? Can we move to Kubernetes? Those are great things to do, but I think a concern that a VP level person would have is how can we have more business outcome from these machine learning models? And so you take a step back and you start wondering, well, how can I improve this and make sure that we are deploying, building and improving this model iteratively in a way that is giving a positive business outcome, right? And so let's look. So the answer is that you need more visibility. You need to know what's going on in production and do your models, so that you can train your models iteratively and increment iteratively, right? So let's look at the existing solutions out there. The first one is model monitoring and observability. And in model monitoring and observability, on the left, you can see the monitoring side, on the top left, wherein you've set up some alerting mechanisms that trigger an alert when a certain metric or certain observed, certain thing that you're watching for the model goes above a threshold, right? So you can see like, hey, you had set a threshold for the latency of the predictions, and the moment the latency starts going higher, there's an alert, somebody gets woken up in the middle of the night, and the DevOps team will serve it. Or you may have other data scientist-oriented monitoring as well, which is, let's say, you suddenly see there's a huge shift in the color scheme, and maybe some library upstream change that instead of sending data as RGB is now sending the data as BGR, right? And so you really want to detect those soon. The other thing we've seen in monitoring and observability is outlier detection. So you use some sort of an embedding space to understand how these models are working, and you what data is this model getting? I'm sorry. And when you plot them together, you might be able to find like, hey, there's an outlier here, and so you suddenly start reacting to this and figure out what that outlier is, and so on. Another observability thing that that some of the people here will talk about and is detecting data drift versus the training data. So during training data, for example, for one feature, you had 4 values, and the rectangles or the bars in white show you what the training distribution of those features were, of that feature was for all those 4 values. But in prediction during production, you see this shift in this data. And so now you're curious, like, hey, what happened to value 3? Why has it changed so much, right? And so you can start investigating and slicing and dicing your data to figure out what's going on there. Another way to detect drift is in comparison to a different time period. So for example, you can say week over week, what has the drift been? And so for example, here you can see the 2 black lines for some metric. The metric here doesn't matter as much as observing that, hey, there is, our weekly estimate is like this, but then suddenly this last week we saw a spike on Friday, and now you want to figure out what is going on. And maybe it was a heat wave. Maybe it was something that has happened in the model, the libraries that happened that were updated upstream. Maybe some new release came out with pip install, and everything got upgraded automatically, and suddenly there are more errors in the data. So you can compare with different time periods and see what's going on. The next visibility tools we have are model explainability, and again, a few of the people here will talk about that today. So on the image on the left helps you explain one prediction. Why was this image predicted this way? And this is a method called anchors, wherein you're taking superpixels, masking them out, and sending it through the model to identify which are the superpixels that were important to identify this dog as a beagle, right? And so this kind of helps you. This is the anchors method, which will help you explain that one prediction. But you can explain the model, the impact of each feature on the model as a whole, which you can see in the images on the right. There are features on the left-hand side, and what are the feature values, low and high, low being blue and high being red. And you can see the B-swarm plot of how much is this affecting the final output score in terms of, you can see that on the x-axis. And this is called SHAP, right? And so, for example, if you look at age, the way I read this is, hey, the age seems to affect it. Like if the age is low, the output value is higher, and if the age is high, the output value is lower, right? And maybe you can use that for identifying biases or some other schemes like that. But let me make a case for why, apart from these, data, apart from these things that you can look at from a quantitative perspective, why is it important to look at visual inspections? And before I do that, I think let's just understand we have been using this visual inspections method all along, right? So for example, what we see is when we are training models, we are doing error analysis. And for example, you have some confusion matrix, and there is some confusion in there, as with this red sign. It seems like there are many false positives. So you look it up. This image is from the data-centric AI challenge. One of the contributors, Stu BK, has put this up on their blog. And this shows like, hey, the data-centric AI challenge was about identifying Roman numerals. But if you look at this image, number 2 at the bottom line, or the bottom row, you'll see that somebody has drawn a smiley face. And so suddenly, when you look at the data, you understand that there is something going on here that you might say, hey, I need to delete all of this data, right? Another example is of Martin09, a contributor, and who's trying to detect these thousands of things, and I don't really want to get into what they are, but thousands of things inside this image. You can see the ones that the model has successfully detected using that are boxed in colors, but you can see that a lot of them are missing, right? So what this person is recognizing is, hey, I'm missing out on a lot of these, and then they ask a question on GitHub. And so the answer here was that their config was off, and they just had to increase the number of maximum objects they could detect here. But it could easily have been a model error where they were doing something, or the model was not the right fit for this kind of a large object detection use case. Another place where we already use visual inspection is reviewing label data. So I had there was a student based out of med school who was trying to identify how can we use AI to detect malarial parasites in peripheral blood smears. So on the left-hand side, you can see an annotated data. There's red blood cells floating around, and within those red blood cells, you can see this mask, the super red mask that is the data ground truth for the parasites in these cells. But the pink boxes, you can see that some of these are missing, right? And so there was a problem with the reviewing label data. Now, in this case, it's a medical student. If you're in the medical domain, you want your doctors and your trained professionals, pathologists, to be looking at this data, right? And so they might be able to look at it and identify something that you as a data scientist might not recognize. The image on the right is from a paper by Clean Lab, a great tool to identify incorrect label data. The top left image, you can see that Clean Lab was able to identify in their paper that this MNIST data was actually a 7. So you can see that the ConNet guessed that this was a 7, but the given annotation for this was a 4. And so you identify these label errors, and the ones that are in the red boxes are the labeling errors, right? So visual inspection helps you identify, just confirm whether the stuff that you're doing to improve the data is correct or not. Escalations. I want to give another example of a customer who's monitoring this factory floor, and what they're trying to see is, there's this robotic arm that is moving around, and it moves in the y-axis, so it moves back and forth. And what they really want to do is stop the arm moving if somebody enters that yellow door on the bottom, right? And you cannot have false negatives here. Now, during prediction, you don't know that you have a false negative because your model has predicted something with a probability. That probability was less than 0.5, and you don't know whether the person actually entered. So what you might do is, something that is in the 0.4 range or 0.3 range, where you're not as confident that there's absolutely no person, you can escalate it up to a human who's watching it and saying, wait, hold on, this robotic arm needs to stop. They'll press the red button and everything will stop, right? And so you really want to have escalations where things like security and safety are super critical. You also have visual inspection during escalating. For example, when there is an error in the data. In this case, let's say age was never entered by the person, and suddenly your model cannot predict. And so you want to escalate it to an expert who can identify, hey, what can we do even if we don't know the age about this person? And so now that we have understood that, hey, visual inspection helps us in many different places in the past, can we use it to our advantage as we are developing this MLOps pipelines and as we are improving our models in production? And you've seen this AI is equal to data plus code equation from Andrew Ng, data-centric AI talk. I'd add people and processes to that, right? And so data and code is what is left after the people and processes go home, right? But people and processes are very important. And so we believe you need to take a holistic approach to identifying and improving AI and not just focusing on the data and focusing on the code. That is obviously very important. And so by holistically, I don't mean don't look at data and code and look at people and processes. I mean, look at everything, right? And that is when spot checks help. Spot checks, you can look at different places as the data is moving through your MLOps lifecycle to figure out what exactly is going on, and then iteratively improve your model. If you spot checks is not hey, you don't need model monitoring and observability and explainability. You only need spot checks. That is not what I'm saying. Spot checks is addition to these in a tool that you can use to improve your model more proactively than reactively, right? So looking at the word spot check, you've heard about it on manufacturing when you manufacture a batch of stuff. So you go there and you randomly sample let's say 10 objects out of all those manufactured to see if there is statistically significant sample of that data to make sure that, hey, everything, all our data, all the things that we've manufactured is correct. In the ML lifecycle, what spot check means is to regularly inspect that sample of data as it moves through your ML lifecycle. And the reason why you should do it, well, it'll help you catch defects early and hypothesize improvements and iterate fast. So it's super critical if you want to improve and iterate fast, right? And at the end of the day, like we said, the VP pointed out, we need a better business outcome for our models and not just improve model accuracy or not just improve, use the best state-of-the-art MLOps platforms and tools out there. How do we do spot checks on predictions when we have deployed a model? So there's 4 simple steps. One is from all the predictions that are going on, you sample the data that you want to inspect. Now you can use a random sampling, like let's say probability 10% of your data, right? But the other thing that you can do is be smart about how you sample this data that you want to look at by looking at metrics that we've known from active learning or some other place, like in this case, entropy. That's the formula for entropy, by the way. And so you sample this data to inspect, you collect it, and then show it in the UI to a data scientist, ML expert, a product person, a domain expert like the doctor we talked about, and just get some feedback, like get eyeballs on these batch of predictions. And this can be a simple feedback as a thumbs up and thumbs down. In this case, hey, is this a dog? Thumbs up or thumbs down, right? Simple enough. And you can, as a data scientist or a machine learning practitioner, MLOps person, as you start going through these, you'll realize like, hey, there is a pattern that I'm observing, or, oh, we never accounted for this use case, right? And so that's where you hypothesize these improvements, like this is what we can do. And let's say you have a Scrum process and you create these tickets to improve and iterate on the model. And then you repeat this at a regular cadence. Awesome. But spot checks can help you in other places in the ML lifecycle, right? And so we talked about the prediction, but let's look at the other places where spot checks can be helpful. Now, spot checks can help you reduce your knowledge gap with domain experts. I was talking to a customer, and they were building a medical. They were building a model in the medical domain. Now, they were a data scientist, and so they, even though the doctor was sitting halfway around the world, what they had to do was at one point sit down and understand how leukemia was detected in blood cells, right? And so now they are a pseudo expert for at least day-to-day operations of like training the model. But they soon realized like getting that doctor inside the loop of how you can quickly see model predictions and identify things would help. And so in this case, in the lymphocytes case, maybe there's a way in which the lymphocytes manifest or like are observed, which is not a textbook case. And so the data scientist obviously doesn't know it. The doctor knows it. So we want to get the doctor's feedback as soon. Maybe you're you've just started your MLOps journey, and there are some experts you would always turn to for advice. By having them look at these predictions, they can come back and give you feedback like, hey, you're using faster RCNN. Why don't you try a different backbone that'll help you solve this particular problem? Or if you're using YOLO, like maybe they'll say, hey, did you realize YOLO V7 got launched? And so a senior machine learning expert would help you guide, like, hey, these prediction problems that we see in this spot check data, maybe this other model can help you avoid them. Improving data quality for future model improvements. So for example, you already know about this data-centric AI approach where you are improving the instructions so that you're getting model labels very consistent. And getting consistent labels is key to having successful model trained, right? So on the left-hand side, you see that the annotators are marking bicyclists in 2 ways. One marking the cycle and the bicyclist as a pedestrian, the other one marking both of them together, right? So the natural thing to do is improve the instructions so that you get these consistent labels. And you'd only understand that this is happening when you spot check the data and visually inspect the data as it moves through your pipeline. But one thing you might think about using spot check for, and spot check is not, it is not a tool for you to name and shame people or fire people who are not good at the job, right? Spot check is a way to help you improve the model proactively and get people together. The people in the process are part of this, the AI and machine learning lifecycle. So you want to improve the process. You want to up-level your people. And so if there's an annotator sitting halfway across the world, you don't necessarily just want to say, hey, this annotator is not doing a good job. What you want to do is improve this process so that they become improved annotators for your job, right? And so that's what spot check is about. It's about proactively making a positive improvement in data, code, people, and process, right? Another place where spot check is really helpful in detecting data biases, right? And this is super important, as we've understood recently. An image on the left, taken in April and published by the DALL-E team, shows the initial risk and limitations of DALL-E. So DALL-E can generate images when you give it text, right? So the text given here was CEO, right? And you can see this is heavily skewed towards male. So there is a known bias that you now have identified when you look at these images, and then you're like, you know what, our model is just biased. It's not generating the things that we want. And you can only do this from having a team of these ethical AI champions that can help and guide you. So why not, when you're predicting stuff, have them look and spot check your data and make it really easy for them to give you feedback like, hey, I think that there is this bias that potentially might be in our case, so let's try to improve that, right? And this, again, I'd say is super important in doing this. Refactoring. So updating the taxonomy. So when you start looking at these images, you start trying to figure out like where can you improve, and it might actually be the ML problem framing that might have been a problem. So if the image on the left, there's a nice solid line, solid curve that shows you what the class separation are, but there is intra-class variance within the points on the left, and so on the right, and so you can actually remove this using you can create a new taxonomy or subclass to help you identify these defects. The next one is you can identify some improvements to your code when you're debugging the model, and maybe Python 3.10 has a new typing feature that you want to use, so you can go ahead and use that and do some model code and refactoring and improve the way it works. You might also involve some business-sized stakeholders. So a good example I'd give you is one of the customers we talked to. She was a product manager, and they were detecting stuff on a manufacturing line using computer vision. The person who was talking to the actual customer was a sales engineer, right? And they used to come back with feedback like, hey, this is working, this is not working. And so as a data scientist, you really want to bring them into the loop and get them, who are the stakeholders, as part of your cycle. And so spot check can help you do that. Finally, and not least important, is reducing risk and complying with regulations. Was there PII information used? You've obviously taken steps beforehand to stop using PII, but when you're spot checking, you might realize like, oh, we're using name is somehow coming to the prediction model, and name can be a pseudo marker for a race or ethnicity, and so we should stop using it, right? And did we store any of it? Are we going to use it later? The GDPR implications thereof. There's a lot of stuff to deal with. And also, like, hey, you made this call. If we are in a financially regulated or a regulated industry, you want to make sure that somebody who has the expertise is spot checking these predictions to make sure we are complying with all the regulations. And so at AI Hero, we use spot check to help our customers improve our models. For example, so AI Hero helps product teams launch AI-powered features without the need to hire a data science team, right? And so, like the teaching aspect of AI that I mentioned, you see the define, teach, and use 3 channels that we've seen the diagram for so often. With AI Hero, we want to provide these routines that you can come and regularly do, like every week, right? And improve the model. So the one on the top is reviewing what AI Hero is learning. We use spot check to get feedback from our customers, right? And so the way the spot check looks like is a really simple UI. All the user can do is thumbs up or thumbs down when they look at a text or an image and the prediction for it, or say, I don't know. And that feedback is enough for AI Hero to figure out like how to improve the labels and how to provide better models. The other thing that we are working on with some of our early customers is to get data out of the code and in front of domain experts. So our Python library, you'll be able to use spot check and just send these to an expert who will get an email saying, hey, this data is ready for you to spot check. Please come and take a look at it, right? And to summarize, spot check is this critical MLOps activity that you should have in your MLOps repertoire, right? It's not supposed to replace anything. It's an additional one that helps you proactively improve your model. So there are 3 easy steps. You regularly inspect data and predictions to detect defects early. You create the hypothesis and proactively identify these improvements. And by making these improvements, you improve the future data quality and model performance. That's it. I know we still have maybe 4 minutes for questions. So I'll try to see if there are some questions. Maybe we'll give it a minute. In practice, spot check has been super helpful in my experience in the places I've worked at. It's not only helped, get feedback from data scientists who are very helpful, but also engineers and DevOps people, and getting everybody in the loop, right? And so I hope that you can use spot check as a means to improve your model proactively and not be reactive to how you can improve the model in production. That being said, there's no tools out here to improve, to do spot check, and you might have to build out your own internal visualization, just as AI Hero has done it for its customers, right? So there's a bunch you can do, get text feedback, etc., that you can work on to improve the model. And at the end of the day, like I said, the goal is to improve the business outcome of your models. That's it. Seems like there are no questions. All right. There we go. Thank you so much, everybody.